Welcome to this explainer. Look, if you've spent the last 10, 20, maybe 30 years on the plant floor living and breathing ladder logic, you already know exactly how to make machines work, right? But with the way the industry's moving, shifting over to structured text can honestly feel like a frustrating reset. So today, we're getting into a highly practical methodology, how experienced PLC programmers like us can actually use AI to bridge that gap from ladder to structured text without getting burned by bad code.
All right, let's just dive right in. The friction you're probably feeling when looking at structured text, it's not actually a syntax problem. It's a fundamental shift in your mental model. You're moving away from that visual parallel environment on the left, where you can physically trace power flow across a rung, to a top-down procedural environment on the right. We have to completely reset how we look at execution.
So here's our roadmap for today. First, we'll hit the mental model shift, then the case for structured text, followed by the AI translation technique. Next up, where AI will burn you. Then we'll cover a strict verification workflow, and finally, your next step, the crosswalk. Let's get to it.
All right, part one, the mental model shift.
So the core of this transition really comes down to how we view execution. You know this. In ladder logic, every rung is evaluated every single scan. The state conditions are visually right there in front of you. You can see your XIC and XIO instructions and literally watch the logic evaluate in real time. But structured text, it executes sequentially, much closer to traditional PC languages like C. The code runs top to bottom, statement by statement, once per scan. Because of this, execution order bugs and race conditions, they become completely invisible to the eye. They exist purely in the text structure. You literally can't just trace a green line anymore.
Moving on to part two, the case for structured text. Now let me be crystal clear up front. Plenty of shops out there are going to run ladder only forever, and honestly, they should. If you're dealing with machine safety-heavy, maintenance-facing applications where a tech needs to troubleshoot a line at 2 a.m., visual power flow is king. No argument there. But there are objective reasons to build up your structured text fluency right now. Complex stuff like parsing packets for comms protocols, managing massive arrays of UDTs, or building out recipe and batch logic with crazy conditional branching, it is dramatically more compact in ST. Plus, vendors heavily pushing IEC 611 Pre-13 platforms like CODESYS, TwinCat, and Siemens SCL, they're making high-level languages the absolute default for new equipment. Being fluent in both ladder and ST just makes you vastly more adaptable across all these different vendor ecosystems.
Okay, part three, the AI translation technique. So here's the golden rule. Absolutely do not use AI to write new logic from scratch, period. Instead, treat it like a real-time Socratic tutor. Here is the step-by-step. Step 1, start with a rung or a routine that you wrote yourself and that you know for a fact is functionally correct. Step 2, explicitly state your target platform. Never just tell the AI, write this in structured text. You have to specify Rockwell Logix 5000, Siemens TIA Portal, or CODESYS, because the syntax and the underlying function blocks differ wildly between them. Step 3, demand the AI explain its translation to you line by line. Make it tell you why it structured it that way. Step 4, document this into a personal reference. And Step 5, iterate this entire process on real plant logic. I'm talking actual interlocks and sequencing, not just basic toy examples.
That brings us to part 4, where AI will burn you.
Listen, we need to tear down the specific failure modes here because AI will absolutely fail you if you aren't careful. There are 3 areas where it consistently gets it wrong. First up, edge detection. AI frequently assumes the ladder one-shot is just naturally built into raw ST. But in industrial reality, for a lot of platforms, you have to explicitly instantiate an RTrig or FTrig function block and call it every single scan. Second is retentive memory. AI routinely mismanages which variables need explicit retain attributes during power cycles. It'll spit out ST that looks perfectly fine, but it behaves completely differently after a power loss than your original ladder logic did. And third, scan cycle timing. AI simply doesn't understand the complex timing assumptions that you baked into your original rung order.
And that leads us to a massive, massive pitfall. Confident, fluent, wrong syntax doesn't look like an error, it looks like code. AI will boldly hallucinate instructions or function blocks that straight up do not exist in your specific IDE or firmware version. Think about it. It has no clue what's in your installed add-on instructions library or your specific CODESYS dependencies. This kind of confident but wrong syntax is incredibly dangerous because it entirely bypasses your natural skepticism. It looks completely valid to the naked eye right up until the very second you try to compile it, and it utterly fails.
So why exactly does it do this? Well, generic AI training data heavily skews toward whatever IEC 1131-3 dialect happens to be the most common on public forums and GitHub. It completely ignores your highly specific, vendor-locked libraries. Because of this, you must always, without exception, verify the syntax against your specific IDE's help documentation. Never, ever verify against the AI's confidence.
All right, Part 5, Strict Verification Workflow.
Knowing these failure modes, we have to draw a hard line in the sand here. Never deploy AI-generated structured text directly to a machine, period. Not even in a non-production state. You must simulate or bench test all output first. Think of it this way. You need to treat AI output exactly like a junior engineer's very first draft. You have to manually trace that logic against your original truth tables. Remember, for anything involving safety circuits, regulatory compliance, or just basic physical machine operation, the AI doesn't own the liability. The engineer who hits download and deploys the code, you own all the correctness, and you own all the liability.
Finally, Part 6, your next step, the crosswalk.
This right here is your concrete, actionable takeaway. Build a personal crosswalk document. As you start using AI as a tutor to translate your trusted ladder patterns, things like cascaded timers or latch and unlatch pairs, map them directly to their verified structured text equivalents for your specific platform. Your final deliverable isn't some saved AI chat transcript. The deliverable is this durable personal reference sheet. By building this crosswalk, you are quite literally rewriting your own mental model, creating a rock-solid asset you can rely on for years to come. So my recommendation to you today is simple. Take one single battle-tested latch and unlatch routine, fire up your AI tutor, and build your very first crosswalk entry before your shift ends. Thanks for tuning into this explainer, and hey, happy coding!